Be presenting on moles and molar mass. So the mole is the amount of substance that contains the same number of entities as there are atoms in exactly 12 grams of carbon-12. So they're talking about the isotope carbon, which can be like carbon-13, carbon-14. Specifically, they're talking about carbon-12. So the term entities is kind of like a catch-all if you don't really know what you're talking about. So it refers to atoms, ions, molecules, formula units, electrons, protons, neutrons, any type of particle. And then the third point about this is that 1 mole contains 6.022 times 10 to the 23rd entities to 4 significant figures. This number is called Avogadro's number and is abbreviated as N. So this gets used a lot. Moving on to the molar mass. The molar mass of, which is usually like a really fancy M, like in cursive, of a substance, is the mass per mole of its entities. Atoms, molecules, or formula units. So like if you have a compound, you would have the mass of each element in there. But if it's just one, you would just have the one mass. For monatomic elements, see here, the molar mass is the same as the atomic mass in the grams per mole. So the atomic mass is simply just read from the periodic table. So for example, the molar mass of neon is 20.18 grams per mole. Moving on, this is a chart that helps us understand the information that you can gain from just the chemical name of glucose, or the chemical formula. We have the molar mass there. So we're going from carbon C, hydrogen H, and oxygen O. Those are our columns on the top. And then we have atoms per molecule of compound, moles of atoms per mole of compound, atoms per mole of compound, mass and molecule of the compound, and the mass and mole of the compound. So in carbon 6, in carbon, the number 6 here, so you have 6 atoms. Hydrogen 12, 12, oxygen 6, 6. So the moles are gonna carry over, so 6, 12, 6. And then here is where you're inserting Avogadro's number to figure out your moles. So 6 times 6.022 times 10 to the 23rd power. Try to say that as many times as you can. Say it 3 times fast. 12 times 6.022 times 10 to the 23rd atoms. And then for oxygen, the same for carbon, because we have the same amount of elements, or atoms for elements. So 6 times 6.022 times 10 to the 23rd atoms. So the mass per molecule of the compound is 6 times 12.01 AMU. Pretty sure that's your mass. Which equals 72.06 AMU. AMU is like a measurement of units. So 12 times 1.008 AMU equals 12.10 AMU. And then for oxygen, 6 times 16.0 AMU equals 96.00 AMU. My bad. And then the mass per mole of compound for carbon is 72.06, which is what you got from the previous thing. Then for hydrogen, it's the same, the answer from the previous thing, 12.10 grams. And then oxygen, the answer from the previous, which is 96.00 grams. Moving on, this is interconverting moles, mass, and numbers of chemical entities. So here on the first two, you'll notice that they're kind of interchanged, and the same on the second one. So if you're trying to figure out your mass and you have your number of moles, you can times it by your number of grams divided by the number of moles. So these cancel out and give you your answer. So that would go away, that would go away, and you would just be left with your answer. And then the number of moles, say you know your mass, but you don't know your moles. So you can flip it and use this, where mass per gram times 1 mole times divided by the number of grams equals. So here is trying to find out the number of entities per compound or element. So you are going to do the number of moles times Avogadro's number, 6.022 times 10 to the 23rd power entities divided by 1 mole. And then in the previous one, if you don't know how many moles you have, but you do know how many entities you have, you flip it. So it's number of entities times 1 mole divided by Avogadro's number, 6.022 times 10 to the 23rd power. Okay, so moving on, there's mass mole number relationships for elements. So we're only looking at this side. Mass of element, there is your the mass that I was talking about, how they do it in a specific font, grams per mole. And then the amount of mole of element, Avogadro's number, how we showed it earlier, and that gives you your atoms or molecules of element. And then the amount mass number for relationship for compounds. So elements is just one type of element, and compounds are multiple elements put together, whether those be the same kind of element or different elements put together. So you have to find out each individual mass. So you get the mass of the compound. There's your molecular, your fancy M. The amount of moles of the compound, and then the amount of moles of elements in a compound. So you would go by each one in the compound. So, like shown previously, for glucose, it has 6 carbons, 12 pretty sure it's hydrogens. Yeah, 12 hydrogens and 6 oxygens. So that's a compound. That's why we got each individual molecular mass. So that's what it's asking you to do here. And you do all of this by Avogadro's number, and you get your molecules or formula units of the compound. Moving on, here's just a little example before I leave you. Calculating the mass of a given amount of element. So say you have silver with its name is shortened to Ag. It's used in jewelry and tableware, but no longer in US coins. How many grams of Ag are in 0.0342 moles of Ag? So to convert silver, which is our Ag, to the mass of silver in grams, we need the molar mass of silver. So the amount of moles of silver multiplied by the mass of Ag, which is still silver, which is 107.9 grams per mole. This multiplied by this gives you your mass of grams per silver. So showing that, here is your 0, you're pulling it from the equation up here, 0.0342 moles per silver times 107.9 grams of silver. So this over here is the mass that we had gotten. We're carrying down over here, and then this from the equation over here, we're carrying down over here, and we're putting it over 1 mole. These moles cancel out, which leaves us with 3.69 grams of silver. So these were just some bases on how to understand the conversion of elements into moles and how to use those units. Thank you so much for listening to me, and hopefully you learned a bit, because I learned a bit too.